Hi friends, welcome you all to this session once again. So today we'll be dealing about the two important topics, which is the temperature zones and the distribution of temperature. So this is a continuation of the previous videos, and today we'll deal with temperature zones and the distribution of temperature. So before starting, we'll start with the motivation as usual. The story goes like, I read a story of Buddha and his disciple Ananda. Okay, so Buddha and Ananda were walking towards a town and they want to reach the town before the sunset. Okay, so it will be easy for them. So they were walking towards the town, and they don't know how much distance it is. So they asked the villagers, they asked the old man, how much is the town? Then the old man replied, it is just two miles from here, you are very near. They just walked 2 miles, they didn't find the town still. They asked the old grandma, she told that you are very near, just 2 miles. Like that, each time they went, one people are saying very near, it's just 2 miles, it's just 2 miles. And Buddha always had a laugh when someone is saying like it's just 2 miles, then that person and Buddha will just smile at each other. Okay, this was happening, and finally they reached the town before evening. Okay, so actually it was 10 miles. Okay, then Ananda got so much frustrated and he was saying to Buddha like, this village people are so much of cheat and they are saying lies and all. Then Buddha calmed him down and Buddha said that I know the distance, it is 10 miles. I have been to this village many times and I know it is 10 miles. But these people were not saying lies. Actually, they were in a profession of motivation. So that's the reason why Buddha and those people were just smiling at each other, because they both know that it is 10 miles. But still, they told that it is just 2 miles, and they pushed them towards before the sunset they should arrive. Okay, then Buddha told, if I have said you earlier like it is 10 miles, then you will definitely say that we will not reach 10 miles before evening, so we will not go. You will change the plans. So I needed to motivate you. That's why these people they were in the process of motivation. So this is the same way for aspirants also. You will be writing your test series and all. If your names are not appearing in the leaderboards, just give a small push. Just motivate yourself and give a small push. If you are studying for 6 hours, just motivate and try for 2 hours more, like 8 hours. If 8 hours, just give for 10 hours and study smartly, and just a small push may reach to the final day where you can see the name in your merit list. So that is the motivation, and with that positive note, we will start the session today about the temperature zones. Okay, so basically this is the Earth and Equator, Tropic of Cancer, Capricorn, North Pole and South Pole. Okay, this Earth has been divided into broadly it has been divided into 3 temperate zones. So first I will explain what are the temperate zones. One is the torrid zone, second is temperate zone, and third is the frigid zone. So what is this torrid zone? You all know Equator is here, Tropic of Cancer is here, Tropic of Capricorn is here. This area from Tropic of Cancer covering the equator and till Tropic of Capricorn, this area is known as the torrid zone. So we all know sun is here. Okay, sun is here. Sun's rays will fall vertically on the equator. This is during equinox. At the northern solstice, what happens? Sun will go till here, till the Tropic of Cancer. Again equinox happens, it will again come to Tropic of Capricorn during the winter solstice. Again it will go back to equinox. So sun will trace only this much area. Sun will not go here and all. Okay, from Tropic of Cancer to Tropic of Capricorn only, sun will change its position. Okay, that is the basic. So that area is known as the torrid zone. Okay, so equator is here. So before I explain this torrid zone, I like to ask a simple question here. Where is the temperature maximum? At the equator or at the tropics? Where the maximum rainfall occurs at the equator or at the tropics? That's the question. The answer is at the tropics only. Okay, at the equator, actually the temperature is not that much high, or rainfall is happening that much, because at the equator, of course, at the equator temperature is maximum, but what happens is up to beyond a certain extent, the temperature becomes more and more maximum, and it leads to, if temperature is maximum, then evaporation will also become maximum. When evaporation is happening more, then it leads to more condensation and more precipitation and more rain forms, or more the cloud formation happens at the equator. Okay, so equator is related always to more cloud formation. Okay, so more clouds are formed at the equator because of high temperature, which leads to high amount of evaporation, which leads to high amount of condensation. As a result of condensation, more clouds are formed at the tropics. So when more clouds are formed at the tropics, it will not allow the incoming short waves of insolation to enter inside. So there will be an obstruction over beyond a time. But in the tropics, there is not that much of temperature. So temperature is somewhat mild when compared to equator. The tropics, the temperature is somewhat mild when compared to equator. So evaporation is reduced, so precipitation is reduced, condensation is reduced. Everyone is somewhat reduced with compared to equator, and there is not that much of clouds formed at the tropics. So insolation is maximum at the tropics and not at the equator. That is the one thing I need to clarify you. This is because of the cloud formation. So now we'll come to the torrid zone. Torrid zone is the region tracing from Tropic of Cancer to the Tropic of Capricorn. This area is known as the torrid zone. So what happens here is, you all know this area, sun is in these areas, sun will directly be overhead. Okay, so temperature will be at the maximum or it will be at the peak. So there will be good amount of rainfall and good amount of temperature is there. Okay, that is about the torrid zones. And torrid zone forms the hottest regions of the world with 2 annual seasons of wet and dry seasons. So what are the areas coming under this torrid zones? We can see the areas include most of Africa, South Asia, Indonesia, New Guinea, North Australia, South Mexico, Central America and Northern South America. Okay, just take out your atlas and you can trace where is Tropic of Capricorn, locate where is equator, where is Tropic of Capricorn, and you just study what are the regions coming under these belt. That areas just you mug up, those areas are known as the torrid zones. Okay, so that is the first temperate zone. Second, we will go to the next temperate zone, which is the temperature zone, which is the temperate zone. Okay, this temperate zone falls between the torrid zone and the frigid zone. It is in between. Okay, like a cream cake, it is in between the torrid zone and the frigid zone. So what happens here is, since it is between the torrid zone and the frigid zone, this torrid zone is so much hotter. This frigid zone is so much cold. Okay, since it is between, the temperature is very mild here. Okay, at the torrid zone, temperature is very maximum, but here the temperature and weather is somewhat mild in the temperate zones. So in temperate zone, there are 4 seasons like spring, autumn, winter. Spring, summer, autumn and winter happening in the temperate zones. 4 seasons are happening here. And what are the regions coming under this temperate zones are areas like Great Britain, Europe, North Asia, North America, North Mexico, and South temperature zones include South Australia, New Zealand, Southern South America and South Africa. These areas you can just see in your map. Just note down what are the areas which are between the Tropic of Capricorn and this frigid zone, which is the Antarctic or Arctic. Like this, you can locate the areas and just study what are the regions coming under the temperate zones. That is one thing. The next, then the last temperate zone is the frigid zone. This frigid zone, you all know, this frigid zone forms between the Antarctic Ocean and the South Pole in case of Southern Hemisphere, and Northern Hemisphere between the Arctic Ocean and the Northern Pole. That area is known as the frigid zone, and these areas are extremely cold. Polar climate is there, extremely cold. Most of snow and ice are formed there, and temperature is very much reduced there. And there is also not that much of precipitation there, so rainfall is reduced there. So climate is so harsh and weather conditions are extreme, and human settlements are not found that much in the frigid zone. So that is about the temperate zones. It is broadly classified as torrid, temperate and frigid zone. Torrid zone falls in the between the areas of Tropic of Cancer and Tropic of Capricorn. Here the extremes, the weather conditions are very extreme. One important point to note here is insolation is maximum not at the equator, but it is maximum at the tropics only. Okay, so this tropic zones are coming under the torrid zone. So weather is maximum and temperature is also maximum, and rainfall is also maximum here. But temperate zone, it falls between the torrid and frigid, so the weather conditions are mild and it is very cool, or what to say, it is human settlements can be found there. Okay, but in the frigid zone, it is so much of cold and it is polar climate are experienced there, and human settlements are not that much found in the frigid zone. These are the temperate zones. Next we will see what are the factors actually responsible for the uneven distribution of the temperature on land. See, because the temperature is not evenly distributed. See, in the torrid zone, temperature is maximum, temperate zone it is mild, and frigid zone temperature is so much decreased. Why this variation is there? Why this variation is there? That factors we will see. The first factor is the latitude. Why latitude? Because you know, depending on the latitude, the angle of incidence, okay, the angle of incidence goes on decreasing from the equator towards the pole. In the equator, you all know sun will be there, so vertical rays at the equator. On the other hand, if you go towards the pole, then you will experience only the oblique rays. So vertical rays, smaller concentration, so high temperature. Oblique rays, it is larger areas are covered, so there will be dissipation of heat, so the temperature is reduced in the oblique rays. So latitude is an important factor for this uneven distribution of the temperature. That is the first factor. Next factor is the land and sea contrast. Okay. if you can see in northern hemisphere you can see so much of land, and in southern hemisphere you can see so much of oceans. Okay, so this uneven match leads to the variation in the temperature also, because you all know the concept, the land gets heated up and cooled up very quickly than the water surface. This difference of land and ocean in the northern and southern hemisphere leads to is also an important factor in deciding the temperature variations also. Okay, so remember, in northern hemisphere there are so much of land, and southern hemisphere there are so much of water bodies. This will speak more clearly while coming to the oceanography, or while dealing about the currents and all. This will be very helpful. Like northern hemisphere there are more land, and southern hemisphere there is so much of water bodies. That will be more helpful. And next one is the relief and the altitude. Okay, when I say relief and the altitude, it is about the mountains. So these mountains and the reliefs are also a major cause, or is also a major determining factor for the uneven distribution of the temperature. Mountains, plateaus, plains control the temperature by way of modifying its distribution. Okay, mountains act as a barrier against the movement of winds. When the rain-bearing winds, okay, when the rain-bearing or the winds containing the moisture, when they are coming and a mountain is there, then this mountain will obstruct the wind. And you can see there are two sides, rain shadow sides and the leeward side. Okay, in the mountain shadow, see, mountain is here and there are two areas, and the winds are coming from here, means the winds will come, hit the mountain, and the rain will form here only. On the other hand, the rain shadow region will not receive any rainfall. Okay, this you can clearly, so I can say that this mountain or the relief act as a important factor for determining the temperature also. For example, the Himalayas prevent the cold winds which are coming from the Central Asia, and that is why you can see, take the latitude, to open the map, and you can see our Indian, let us say Kolkata, take Kolkata, okay, Kolkata, and spot China. Take a place like take a place like, what to say, Gangsu, a place called Gangsu in China. Gangsu in China and Kolkata in India, both are at the same latitude. But go and check the temperature. Kolkata is not that much cold, but Gangsu is so much of cold. Winters are so extreme there. But in Kolkata it is not happening, since they both are in the latitudes. I told the first factor it is depending on the latitude. So if we go by that, it is not happening. Why? Because Himalayas are there in India. These Himalayas prevent those extreme cold winds from the Central Asia, and they prevent those winds, and that is why Kolkata is not subjected to that much of harsh weather conditions. On the other hand, your Gangsu in China will have harsh weather conditions, because there are no mountain barriers to obstruct the cold winds coming from the Central Asia. So your relief and mountain also plays an important factor in determining the temperature. These factors, it will be very easy, or you may feel that it is like very straightaway phenomena, but these, they can ask a sentence, or they can confuse you, or they can even more make it complex. So make these concepts very clear. So if they try to confuse also, you will be very clever in identifying those complexity. So relief and altitude is the third factor. The fourth is the ocean currents. Ocean currents also play an important role in determining the temperature. That you will know very detailed when you are dealing in the oceanography. I have a separate session on the ocean currents. Okay, so how these ocean currents affect the temperature is, you know, warm currents and cold currents. There are two currents, warm and cold currents. If a current or a mass of air which are tracing out horizontally, if they are hot, then it is warm currents, and if they are cold currents. Very simple. Okay, if those warm and cold currents, if the warm currents increase the temperature through which they flow, the warm currents increase the temperature through which they flow, and the cold currents decrease the temperature through which they flow. Okay, so depending on this warm and cold currents, there are lots of temperature variations in the land atmosphere. Okay, for example, I can say North Atlantic drift. Okay, North Atlantic drift is a very important warm current. That current warms the coastal districts of Western Europe. When you take the map and see the coastal districts of Western Europe, these warm currents blow over that, and there are so much of ports available in the coast of Western Europe. Okay, these ports are made ice free because of these warm currents only, because of this North Atlantic drift only, warm current only, those ports are made ice free. Okay, like this we can say many examples. So my point is, this ocean currents also play a very, very important role in determining or to the uneven distribution of this temperature. If you take Labrador current, it is a very, very cold current, and this Labrador current is making so much of temperature variations, and this we'll talk about this Labrador current and all in the later parts. But now understand currents make a important factor or variation in the temperature. Another factor is the wind. Okay, wind is also an important factor in determining the temperature. Wind also affect the temperature because they transport heat from one region to another. Okay, that is an important factor of the wind. And another is the vegetation cover. How this vegetation cover affects the temperature distribution is, if an area is having so much of vegetation, so much of forest, so much of trees are there, what happens is insulation cannot penetrate deep inside the soil, because see, more number of trees are there, so it is so much of clumsy there, and so sun cannot go inside the soil and all. It cannot penetrate through the forest. Also, there are so much of water present in the leaves of those trees. Okay, so the suns which are received by these trees will be used for evaporation of those leaves, of those water. Okay, so there is no chance of sun penetrating inside the forest and reaching the soil. Okay, so insulation is being affected where there is huge amount of vegetation. If you take a land where there is no vegetation, there is not that much of forest cover, or they are forests are widely spaced, those kind of things, then there is easy insulation and the sun's rays can reach deep inside the layer of the earth. Okay, so that is the one of the factor affecting the temperature. Okay. Next is the nature of the soil. We'll study about the types of soil while dealing in the Indian geography. There are types of soil. We'll study only with the perspective of Indian geography. Okay, don't confuse the study about the soils of the world geography. That is your main part. We are dealing only with the prelims part. So I will speak about these types of soils while dealing about the Indian geography. Okay, so now soil also determines the temperature. If you say you can take a black soil, yellow soil, or the clay soil, they retain moisture. Okay, they can retain the moisture, so that will increase the temperature. On the other hand, if you take the sandy soil, they cannot retain the moisture, or they cannot retain the temperature. So the temperature will be affected, or it will be lower when land where there is a sandy soil. So these clay soil and black soil, they can retain the heat which they are absorbed. On the other hand, your sandy soil, they cannot retain or they cannot hold that temperature or moisture content. So they will easily radiate. So these sandy soils, there will be low temperature only. On the other hand, regions having the sandy, black soil and yellow soil and all, there will be more temperature will be increased there. So that is another factor. Next important factor is the slope. Okay, slope and the slope aspect. Okay, so the slope is an important factor affecting temperature. So these are gentler slope. Okay, these are gentler slope and these are steep slope. So where insolation will be more, because here sun will directly fall on these slopes. On the other hand, here the sun cannot fall directly. The sun's rays will not fall vertically over these surfaces. These are steep slope and these are gentler slope. Okay, so there will be so much of insolation, maximum temperature occurring at the gentler slope than the steeper slope. Okay, so depending on this, you know, when sun is falling more, then we have studied about the mountain breeze and valley breeze also. That also you can bring into this picture. So my point is, the slope also plays an important role in the factors determining the temperature, variation in the temperature. Okay, greater concentration of solar energy per unit area along gentler slope raises the temperature, while its lesser concentration along the steeper slope lowers the temperature. So gentler slope will have maximum temperature and the steeper slope will have the low temperature because of the slopes. Okay, you can take the Himalayas. If I am saying about Indian geography, if you take Himalayas, the southern slope of Himalayas, they are very gentler. On the other hand, the northern slope of Himalayas are very steeper. That's why you can see there are human settlements, or there are more number of cultivations in the southern slope. In the northern slope, there are not human settlements there found there. Okay, because of this only. When here it is, temperature is very much low and the weather conditions are very harsh here, but here it is somewhat moderate and people can live. That is an example for this slope and aspect. So that is the end of this temperature zones and factors which are responsible for the variation of this temperature. Okay, next we are going to study about the distribution of temperature. Distribution of temperature, there are two topics, that is, one is the horizontal distribution and one is the vertical distribution. Okay, so first we will see about the horizontal distribution of temperature and next we will see about the vertical distribution of temperature. So we have talked about the different temperature zones like torrid zone, frigid zone and temperate zones, and also about the factors which are responsible for this distribution of this temperature. That also we have seen. Next important topic is the horizontal distribution of temperature and the vertical distribution of temperature. What do you mean by horizontal distribution of temperature? The distribution of temperature across the latitudes over the surface of the earth is known as the horizontal distribution. On the other hand, your vertical distribution is the in a vertical way. How the temperature is distributed in a vertical way, that is known as the vertical distribution. So first we will deal about the horizontal distribution of temperature. So first, while dealing about this how this temperature has been distributed over the latitude, then we have to know about, we have to study in terms of isotherms. Isotherms are nothing but the points which are connecting the temperature of equals, okay, equal temperatures. Isotherm is a point, if you take a 20 degree Celsius isotherm, so it will connect all the places where it is 20 degrees Celsius. That is isotherms, okay. So we are going to study this horizontal distribution of temperature with regards to this isotherm. Regarding isotherms, we will study the isotherms of the isotherm months of January and July, because during January and July only both the extremes, winter and summer, happen. So we will study the isotherms of January, and also we will study about the isotherms of July. First we will take about the January season, okay. So in January season, what is happening? The sun is at the Tropic of Capricorn, okay. Sun will be at the Tropic of Capricorn, southern hemisphere. So at the northern hemisphere, there is winter. Sun is not overhead there. So in the northern hemisphere, please please listen carefully. I am dealing with the horizontal distribution of temperature, and we are taking or scanning the isotherms in the month of January. In January, it is the sun is at the Tropic of Capricorn. So it is summer in the southern hemisphere and winter in the northern hemisphere. So since it is winter in the northern hemisphere, what happens? The land mass will have a lower temperature compared to these oceans. That you all know, because these land masses will absorb the heat and radiate the heat very quickly, but these oceans will absorb the heat and radiate it very slowly. So this heat, okay, heat will be remaining here, but in the land already the heat would have been radiated, because sun is at the Tropic of Capricorn. So there is winter here. So land mass will have a lesser temperature and oceans will have a higher temperature. So now if you draw a isotherm, let us take, if you are drawing an isotherm of minus 10 degrees Celsius. So just isotherm is nothing but a line which will connect the equal temperature. So if you are drawing minus 10 degrees Celsius, land is very cool, okay, land is very cool and temperature is like minus 10 degrees Celsius only. So it will come like this. Isotherm you can draw, when you are drawing isotherm minus 10 degrees Celsius, it will trace like this, it will go, okay. When coming to the ocean surface, ocean will not be having minus 10 degrees Celsius. Obviously, ocean will be having more temperature. The temperature of the oceans will be more. So automatically this isotherm of minus 10 degrees Celsius will deflect towards the polar, because this isotherm will search for a temperature which is lower, like minus 10 degrees Celsius. So this isotherms will be automatically get deflected towards the poles. When they are crossing the oceans, these isotherms will be getting deflected towards the poles, because in the poles there will be, poles are always cooler, okay. So there will be cool temperature at the poles. So these isotherms will, in search of seeking those cooler temperature, your isotherm will take a polewards bend when crossing towards your oceans. In the land surface, again it will come to the land surface. Land surface, you know, already the land surface have a minimum temperature, okay. So it will be deflected like this. In land surface, while it is coming, it will be deflected. So that is the point. So while your isotherms are crossing towards the land, already the land temperature will be so much reduced because of the winter in northern hemisphere. So your isotherm will bend towards the equator, because it will go into the interiors. Here if you see into the interiors of this ocean, it will be so much reduced. So your isotherm will bend towards the equator when it is crossing over the land, and while it is crossing over the oceans, it will be deflected towards the pole. This is happening in the month of January, while it is winter in the northern hemisphere and summer in the southern hemisphere. Again I will explain. Now we are dealing in the isotherms of January. So what happens when you are tracing minus 10 degrees Celsius? If you are going like this, and the land surface already it is being heat, okay, already it is land is not heat, okay, it is winter in northern hemisphere, so land is so much cold there. So when you are tracing the isotherm of minus 10 degrees Celsius, it will go, and while crossing the land, it will be attracted towards the equator, because it is so much cold here near the equator. It is because land is under the winter conditions, so it will attract towards the equator when crossing the land surface, and while crossing towards the ocean surface, ocean is having maximum temperature, so your isotherm will automatically get deflected towards the polar regions or polewards. Okay, that is the concept. So take it in one line. During January, or during the winter seasons in the northern hemisphere, if you draw isotherm, when you're crossing the land surface, isotherms bend towards the equator while crossing towards the land surface, and while crossing through the ocean surface, your isotherm will bend towards the poles. That is the single line concept of this. Now we will take the isotherm of, in southern hemisphere what happens, the exact opposite happens. That's the thing, okay. During isotherm of January, what happens in northern hemisphere, the exact opposite will happen. What is the exact opposite? If you draw an isotherm, while what is happening in southern hemisphere during the January, it is summer here. So the land temperature will be maximum. At the land, the temperature will be maximum, and in the ocean, the temperature will be lower. Okay. So if you draw an isotherm, what happens is, when you're crossing the oceans, automatically your isotherms will deflect towards the equator, and if you're crossing towards the land surface, your isotherm will get deflected towards the pole regions. The exact opposite what happened in the northern hemisphere will happen in the southern hemisphere. That is about the isotherms of January. Next, if we will deal with the isotherms of July month. During June-July month, what happens? Your sun will shift towards the Tropic of Cancer. So it is summer. in the northern hemisphere. So now if you draw an isotherm, it is summer here. So land temperature will be maximum and the ocean temperature will be minimum. So now it is summer in the northern hemisphere. So what happens is, if you draw an isotherm, the exact opposite will happen. What this means, if you are crossing towards the land, the isotherm will bend towards the poles because your land temperature is maximum. So your isotherm will bend towards the poles, and when you are crossing through the oceans, your isotherm will deflect towards the equator. Because of the variation in the temperature of your land and the sea surface, this isotherm will bend. The exact opposite will happen in the southern hemisphere during the June month. So take this very clear. During isotherms of July, when you are crossing the land surface, your isotherm will bend towards the poles, and when you are crossing through the oceans, your isotherm will bend towards the equator. In southern hemisphere, what happens when you are crossing through the ocean? The exact opposite will happen. Okay, vice versa will happen. So this isotherm bend is based on the variation and depends on the season, whether it is summer or winter. If it is summer, then the land mass will have more heat than the ocean surface. If it is winter, then your land mass will have minimum temperature than the ocean. So depending on this variation of temperature, the temperature is distributed horizontally. If you want a cleaner diagram, you can just refer NCERT book. The isotherms of January and July has been clearly depicted in the NCERT. So with that diagram and what I have said, you can clearly understand the concept of this isotherm bending towards the polewards and equatorwards depending on the variation of the temperature. That is about the horizontal distribution. So now we'll study about the vertical distribution of temperature. What is vertical distribution of temperature? The temperature distributed vertically. So when you rise with altitude, okay, altitude in geography means height. Okay, when you rise with altitude, then obviously your temperature will be minimum. That is the concept we all know. Why this is happening? Because of terrestrial radiation. The land is being heated from below and not from above. Because of this, when you rise with altitude, your temperature will be minimum. Okay, this is known as vertical distribution of temperature. The exception to this is known as the inversion of temperature. This exact opposite of this concept is known as the inversion of temperature. Sometimes, in exception, what happens is the nights may be extended. The extended nights or the longer winter season. Because of this reason, the land surface will radiate the heat very easily or very quickly. Okay, and the land surface will become too cooler. Okay, the land surface will become very cool. Cooler means what? Not the land surface, exactly not the land surface, just take 2 feet above. That blanket of air, because of this exception. What is the exception? The longer duration of night or the extended winter season. Because of this, the land surface will radiate more heat and it will start becoming more colder. Okay, so the air becomes very colder and denser, and if air is becoming so cold, it will be increase in density and increase in the weight. So it will stay in the lower surface of the atmosphere, and above if you go, there will be hotter or the warmer air will go above. It will rise above. So once if you go above, when you rise with altitude, the temperature will increase. That is the exception to this normal concept. Sometimes in rare occasions, when the winter seasons are extended or long nights, this scenario happens. The radiation will be so much that the land becomes so cold and the denser air will stay in the bottom and the warmer air will rise upwards. So once you go up, you feel like the temperature has been inversed. That is the case. There are so much exception to this inversion of temperature. The other exception is the mountain breeze and valley breeze. We have discussed about mountain breeze and valley breeze. What happens in mountain breeze and valley breeze? Mountains are there and valley flows are there. What I told, during the night time, the cold denser winds will come from the mountain towards the valley and settle at the valley floor, and this the denser air will be at the valley. Okay, so cold air is there. Cold air is at the valley floor. On the other hand, the warmer air will stay at the top. So once you go from when you rise in altitude, you will find the temperature will be inverse there also. So our exception includes the valley breeze also. That is my case. So this is about the vertical distribution of temperature and also about the inversion of temperature. With that, we are coming to the end of the distribution of temperature. So what we have studied in this session is first we have seen about the 3 temperate zones of the regions, and please I am saying with regard to the temperature zones, we all know it is very easy, like torrid zone, what is temperate zone and what is frigid zone. It is very, from the name itself you can identify what zone is that, but that is not important. UPSC regarding this temperate zones, your map study is very important. Just take out the map and just clearly identify what are the torrid zone, what are the temperate zone, what are the frigid zone, and note down those areas, because in prelims point of view, map questions can be asked like that only. Okay, so regarding areas, be very thorough. In my session also I have told what are the areas, but take out a map and add more areas to that list. What are the areas coming under those torrid, temperate and frigid zone? That is very important. And factors affecting temperature. We have seen some 7-8 factors, how these factors are responsible for the variation in temperature, and we have dealt about the horizontal distribution of temperature. With horizontal distribution of temperature, it is regarding only the isotherms, whether isotherm is bending towards the poleward or equatorwards depending on the summer and winter season in the northern southern hemisphere. Also, we have dealt about the vertical distribution of temperature and the inversion of temperature. With this, the session is over. Next video will be covering about the pressure belts, which is much more important. Thank you.